Hello everyone, I'm right.
Hello, I'm left. You've learned that there's 118 elements currently. So, right, what's the 59th element? What's its atomic mass?
You expressed me 140.9.
What? You can remember this?
Well, chemists created a table of all elements, the periodic table of elements. Today, we're talking about the periodic table.
So, what does the periodic table look like? The first one or the second one? This is the first one, the second one. Neither the first nor the second. And this is the real table, which was created by Russian chemist Dmitry Ivanovich Mendeleev in the year 1869. Whoa! The elements are arranged in a sequence. The first element has 1 proton, the second has 2, the third has 3, and so on. The elements in the same column have similar chemical properties. The metals are on the left, and the nonmetals and the semi-metals are on the right. However, there is an odd nonmetal, hydrogen. It's on the far left.
So, there are 18 columns and 7 rows currently. But there are actually 9 rows. That is, the last 2 lines is actually in the 6th and 7th row. If they are added to the 6th and 7th row, the table will be like this.
Wow,
This is weird, yeah?
yeah.
This is too long. So chemists made the 2 extra rows, which is under this thing.
It's put here. I didn't draw it.
Okay.
Chemists call a row in the periodic table a period and call a column a group. But why there's only 16 groups? There are 18 columns. Well, there is an odd one, just like hydrogen. The 8th, 9th, and 10th columns are in one group.
Wow, that's weird.
There are 8 main groups. The group 1 and 2, which are column 1 and 2. Group 3 to 7, which are columns 13 to 17. And group 0 or group 8 is the 18th column.
You know there are 118 elements, which is a lot of elements. So how can we classify them? The first method makes elements into 3 groups: gas, liquid, and solid. Notice that room temperature is 20 degrees Celsius. Don't ask me why. The chemist said this.
Always a chemist said this.
So, if an element melts at 29 degrees, it will be put into the solid group, not the liquid group. There are 12 elements in the gas group, 102 in the solid group, but there's only 2 elements in the liquid group. One is mercury, or known as quicksilver, which melts at about minus 39 degrees. The other one is bromine, which melts at about minus 7 degrees.
The second method divides the elements into also 3 main groups: metals, nonmetals, and semi-metals. They're further divided into alkaline metals, alkaline earth metals, transition metals, post-transition metals, semi-metals, halogens, noble gases, and non-metals, and also lanthanides and actinides. Oh no!
So, lanthanides are the 8th row, actinides are the 9th row. Okay, the alkaline earth metals, group 1 except hydrogen. hydrogen is the odd one, and some alkaline earth metals, group 2, react violently with water, and some can cause explosions. The heavier alkaline metals are more reactive, and their melting points are lower. Transition metals and post-transition metals react with nonmetals, but not as violently as most alkaline metals and alkaline earth metals. We'll talk about their difference next time.
Semimetals are hot metals, nonmetals. They can barely react with other elements. Halogens, group 7, are very reactive. They form salts with metals. Lighter halogens are more reactive. No! The lightest halogen, fluoride, is the most reactive element discovered. No. It can react with 115 other elements.
Wow!
Noble gases, or group 0, cannot react with other elements naturally. The lighter noble gases are less reactive. Helium and neon are believed as the least reactive elements.
I want to be alone!
I don't want to react. You guys, go away! Here are the only elements that cannot form stable compounds, even with the help of humans now. There are the only 2 elements that cannot react with fluorine.
Ooh, I want to! Hey, play with me!
No!
Play with me!
That guy, go away!
Okay, that's just all for today. In this episode, we learned about the periodic table, periods and groups, and the classifications of elements. Next time, we'll learn about valence electrons.